name's Abraham. I'm a postdoc in the Data Science Institute here at Columbia. I would like to introduce Professor Laura K. Nelson. She is currently an assistant professor of sociology at the University of British Columbia. She specializes in computational methods, principally text analysis, natural language processing, machine learning, and network analysis techniques. All areas of interest that we have in common, to study social movements, culture, gender, and organizations and institutions. In addition, she used her research to examine processes around the formation of collective identities and social movement strategy in feminist and environmental movements, continuities between cycles of activism, intersectionality, and gender inequality in entrepreneurship and STEM fields. In addition, she has taught courses on these topics, introducing undergraduate and graduate students to social science and humanities students to computational methods. She has also published in several journals, including the American Journal of Sociology, Gender and Society, Poetics, Mobilization, and International Quarterly, and Sociological Methods and Research, among others. She is currently on the editorial board of the Sociological Methodology and an associate editor at EPJ Data Science. Please welcome Laura K. Nelson.
Thank you. Thanks for having me here. I know it's an intense semester at Columbia, which I'll mention at the end. So I think everyone here, this is a Data Science Institute, would probably agree that the current moment where we're seeing access to digital data and computational methods is truly revolutionizing the way we understand both ourselves and society. Some of the ways that scholars are using these methods, I am going to claim in this talk, is taking us in potentially a wrong direction, a non-scientific and non-objective direction. So I'm going to offer an alternative framework for how I think we can best utilize this moment to create a radically objective social science with these new data and methods. I'm going to start it off with words from Duncan Watts, because he usually says things the best. Just as the invention of the telescope revolutionized the study of the heavens, so by rendering the unmeasurable measurable, the technological revolution in mobile web and internet communications has the potential to revolutionize our understanding of ourselves. We have finally found our telescope. Let the revolution begin. So what I like about this quote is his focus on the telescope and vision and rendering the unmeasurable measurable, which I will get back to a number of times in this talk. So one of the things that this moment has done, it has revived this idea of social physics. So one avenue that people are taking this moment is through social physics. And this, of course, is not new. It goes back to the 19th century. But this idea that the social world is subject to laws not unlike those of physics, and we should be trying to identify these kind of physical laws of social science. Digital data provides the opportunity to build a physics of society. And in order to do this, we want to be able to state principles that hold for all groups, all organizations, all societies. So this kind of social physics idea that there are these universal principles that we can identify using these methods and data, and this should be the goal of computational social science or complexity science, whatever we want to call it here. The way this is happening empirically, and I'm going to show you some papers just to demonstrate what is being published in big outlets like Science, Nature, etc., is the desire to find these universal patterns in large amounts of empirical data. So this is an old paper in 2011, diurnal and seasonal mood vary with work, sleep, and day length across diverse cultures. So this idea that seasonal depression happens across cultures as diverse as Africa, India, UK, US, etc. A more recent paper, the nearly universal link between the age of past knowledge and tomorrow's breakthroughs in science and technology, the hotspot. So this idea that the citational patterns of hit science papers or hit papers is similar across very different fields. This universal pattern, hot streaks in artistic, cultural, and scientific careers published in Nature. So our careers have hot streaks. So if you haven't had your hot streak yet, hold out, you will get it. But this holds again across these very different fields here. And of course, you can't not mention the scale-free networks, Farabassi's theory that preferential attachment leads to a power law degree distribution. And this holds across many, many different types of networks, from social networks, biological networks, etc. So again, this is the empirical way this is playing out in computational social science, is this desire to find these universal patterns. These universal patterns may suggest underlying universal laws that govern society the way that physical laws govern the physical world, etc. So this kind of can be summed up in this desire to identify the one model to rule them all. And we're seeing this revived again out of Stanford with the large language models that they're building. So these very large language models that model all of language, etc. So we're seeing this over and over again. This social physics, universal laws, etc., trying to capture everything in one model. And that is the excitement of the current moment. The problem with this perspective is it's not actually working. So one of the ways we can assess machine learning models or large computational models is through their ability to predict something. That's what they're built for. That's how they're often assessed, their accuracy. So Matt Zalganik, a computational social scientist out of Princeton, wanted to seize this moment to see if we could use machine learning models to predict life outcomes. So he used the Fragile Families data, which is a really large, rich data set of early childhood variables, and then they tracked people throughout their lives up until they were maybe 20 or 22. So he put a challenge out to the research community saying, I'm going to give you some early childhood data. You build a machine learning model that will then predict life outcomes from those early childhood variables. I don't know, 100 so teams submitted something, and then he tested the ability for these models to predict against a baseline logistic regression. And what he found was surprising to him and quite disheartening. He found that the best submission did not any better than the benchmark logistic regression, and overall the accuracy was quite low for most things that they wanted to predict. We're seeing accuracies at 0.03 here for some of these variables. So he concluded in a paper in PNAS that despite using a rich data set and applying machine learning methods optimized for prediction, the best predictions were not very accurate and were only slightly better than those from the simple logistic bench or regression model. So these results suggest practical limits to the predictability of life outcomes in some settings. So it didn't work. The most sophisticated model didn't do any better than what we've been doing for decades in the social sciences. And back to Duncan Watts, he kind of agrees with this. The real world is complex, he says, is history only plays out once. It's not that we can't predict anything. The problem is that the predictions we most want to make are precisely the ones we can't make. So a lot of the senior scholars, not senior scholars, but the scholars in this field are recognizing and acknowledging the inability for machine learning and computational methods to predict social outcomes. And if they're unable to predict social outcomes, what are they actually doing? Are they leading to a further understanding of anything if they can't do the basic thing that they're meant to do, which is predict outcomes? So my claim here is that this desire for the one model to rule them all, this desire to find these universal laws governing society is worshiping a false god. It's not the way we should be approaching computational social science, and it's not scientific. I am making a very strong claim here, especially aimed at the younger scholars in the room here. It is not a scientific way to approach social science, and it is not an objective way to approach social science. And social physicists or complexity studies people themselves acknowledge this. So Philip Ball, who's a complexity science scholar, says, it's actually not unusual for one model of theory to appear to be supported by experience in one situation, but other models in other circumstances. So he has concluded that a science of social complexity will need to embrace this position of what he's calling pluralistic modeling. So we can't, in fact, have one model that can explain all social situations at all times. We can't find these universal laws or universal patterns. Back to Colladeri et al., who are calling for this social physics, says actually they walked back, right? They said we need this social physics, but it's actually a little bit more complex than physical society, the physical world. Not individuals are the same. Not all individuals are the same. Even if a suitable description of individual behavior were available, scaling it up to groups of individuals wouldn't be straightforward because the fluctuations with respect to the average can be large. So this idea that there's an average individual, and if we explain the average individuals, we're somehow explaining society, doesn't actually work the way it works in the physical world. And we see this again with the inability of these models to predict any meaningful things in the social world. So there is a long history of this perspective, this kind of pluralistic modeling perspective, this idea that the average is not what we want to be explaining. I mean, it goes back to science and technology studies, and it is the framework of partial perspectives and situated knowledges. So this, I think, is a better perspective than the social physics perspective for really pushing forward the way we can use digital data and computational methods to revolutionize, truly revolutionize the way we understand society in a scientific and an objective way. So what does partial perspective and situated knowledge mean? I will use an example from the natural world to talk about this. So there's a documentary on Netflix now called Life in Color by David Attenborough. It's a fascinating documentary. I highly suggest watching it. And one of the questions they pose is, why is the tiger orange? I hadn't really thought about this much. I don't know if people here have thought about this much. Why is the tiger orange? So the tiger has to hunt deer to survive, and tigers aren't very fast compared to deer. Deer are much faster. So the only way they can hunt is get really close to their prey, take them by surprise, and then catch them. And they have to do this multiple times per week. So if they have to get close to the prey, you would imagine that they need to be really well camouflaged. Yet we're seeing bright orange tigers in a green or brown landscape. So why is the tiger orange? Turns out when we look at the tiger, we have 3 color receptors in our eyes. We see orange. Deer, the main prey of tigers, have 2 color receptors in their eyes. So whereas we see this, the deer see this. They don't see the red color spectrum. So the tiger, to the deer's perspective, and the tiger itself, who only has 2 color receptors in their eyes, the tiger appears green, and it blends almost seamlessly into the background that it's against. So why isn't the tiger green? If the camouflage works, mammals can't make green pigment in their skin and their fur. So it's orange because their main prey, deer, have 2 color receptors and they see green. This is the partial perspectives and situated knowledge perspective. The tiger is orange, 2 eyes that have three color receptors. The tiger is green, 2 eyes that have 2 color receptors. Some animals have more color receptors. It would appear a different color. So you can't say universally the tiger is orange. It depends on who is doing the looking and what the context, what the attributes of the thing doing the looking is. This is situated knowledge. This is partial perspective. This was articulated most strongly by STS scholar Donna Haraway. She's a feminist scholar. Only partial perspective, and this was back in the 1980s, only partial perspective promises objective vision. She uses this idea of vision as well. So feminist objectivity is about limited location and situated knowledge. This allows us to become answerable for what we learn how to see. So not only is it more objective, we become answerable to how we're using these methods to understand society. So this framework it was articulated in the 80s, but I think it's particularly productive for our current moment. So I'm going to talk about what that means for machine learning and computational methods and why I think this leads to a more objective social science here. So why does machine learning need partial perspectives and situated knowledge? Why is machine learning a good tool for this kind of framework? And I'm going to talk a little bit about how we can build responsible and answerable machine learning systems using this partial perspective and situated knowledge framework here. So why does machine learning need partial perspectives and situated knowledge? There's a really fantastic book that came out recently called Invisible Women by Caroline Cirado Perez. My undergrads and grad students for probably a year were telling me, you have to read this book, you have to read this book. It's a really interesting book about how the data that we collect and use is designed for men. So I'm going to show a few examples from this book that were most compelling, but there's tons of examples in this book. So the idea here is that a lot of the information systems, the actual technology and tools we build are built around the idea of an average man. An average man is around 6'3". He has a certain body type. One example is crash test dummies. So women are less likely to get in car crashes. They drive less and they drive more safely. But when they get in a car crash, they're more likely to be injured and hurt. One of the reasons is because safety systems are tested on the average, a crash test dummy that is the average size of an average man. So the seatbelts, the airbags don't work as well for women who tend to be smaller framed, shorter, etc. A lot of men are, of course, smaller framed and shorter as well. So women are more likely to be injured in a car crash because the safety systems are tested on a certain body type. Personal protective equipment, and this goes for construction as well as hospitals, are built for the average size of a man and the body type of a man. Women are more likely to be injured on construction sites. They're more likely to be bothered by their personal protective equipment in hospitals because they don't fit women's particular shape and size. And so there's this builds up, this is the military as well, across many situations, women cannot find the protective equipment they need to actually do the job that they should be able to do. And again, of course, the non-average man as well. Voice recognition software built for the male voice. Women are less likely to get their voices heard in these voice recognition software. This may be trivial unless you're in an emergency situation and you need your phone to call 911 and it doesn't recognize your voice. It could actually be a damaging situation. And even the size of the phone is built for the hand of a man, not for a woman. This is also the case in studies of health. So studies of health historically were almost always done on the male of a species, not the female of a species. The idea is that the hormones in the female of the species cause variance, so it's very hard to control for that variance, so it's easier to just do the study on the male of the species. But this has actually caused many problems. So I don't know if people remember this Twitter account that kind of got famous, I don't know, years ago maybe, just say in mice. So there's all of these science studies that are celebrated in journalism, like, hey, we found something to cure Alzheimer's disease, or exercise does XYZ and can prevent aging. And it's almost always done in mice, and they don't say it's done in mice. They imply that it applies to humans. So this Twitter stream just tweets out in mice. The study was done in mice. Really, if we want to be accurate, we should say it's done in male mice. And almost always it's not reported that this is done just in the male of the species, and it's not just mice, it's monkeys, etc. It's just said mice behave this way. This study applies to mice, and it's actually caused a lot of issues. So a lot of drugs, for example, get activated by estrogen. So there are some life-saving drugs that have not been tested because when they're tested on male mice, they don't get activated, and therefore they're assumed that they don't work. If they were tested on female mice, it might get activated and they might go into production, so etc. So it's not that it's a problem to do a study on male mice. We just need to specify that, hey, we're doing the study on male mice. That's the situated knowledge and partial perspective. So this idea that we can have this Mr. Average, right? This average male that can sit in for the universal patterns across society is wrong. It's problematic, and it's leading to actually very damaging outcomes in health, in technology, in industry, etc. So this is why, one reason why, or one example why we really need to be careful when we say this is a universal pattern. Is it a universal pattern that holds for the average, for example, white male? We need to say that. Then we know who the population it's generalizing to. That's very few people, actually. The average white man is very few people, but they tend to dominate data sets, especially the data sets we have access to, Twitter, IMDb, etc. So when we're trying to claim, oh, this is a universal pattern, we need that tweet bot saying it's a universal pattern in the average white male. If we say that, then we can be more responsible for our conclusions. But that's the way that some computational social science is trending, and something that I think we need to pull back on here. So machine learning needs partial perspective so we don't get sucked into this idea that the average pattern is true for all populations. But machine learning is actually a wonderful tool in order to implement the partial perspectives. It's not often being used in that way, but it is potentially really powerful. So how do we view the partial perspective? How do we implement this using machine learning tools? So back to Donna Haraway, self-identity, she claims, is a bad visual system. So when science and technology studies in the 80s was floating around the postmodern system, one of the ideas was we can only study ourselves. We can only study what we know from our own personal perspective. Donna Haraway, with the partial perspective and situated knowledge framework, is actually pushing back strongly against that. She's not saying this postmodern kind of framework where we can only study what we know personally from experience. This is actually a bad way to understand society. We need a technology to help us visualize these partial perspectives. And that's exactly what's going on in the natural world right now with the example of the tiger being orange. So we have these cameras now that can filter out certain light waves or can filter in light waves, so we can actually see what different animals with different color receptors in their eyes see using technology. So when we look at a flower and that's a spider there in the flower, we with 3 color receptors in our eyes would see this. So we can actually render exactly what the world looks like from these different perspectives with the different color perceptors using technology. So we can say, this is what we see, this is what bees and butterflies sees. We can render these partial perspectives in that way. This, I think, is where machine learning comes in the social sciences. This is exactly what machine learning is really good at, and what it can do is it can render these partial perspectives in a very precise way so that we can see from a certain perspective, this is what the world looks like. From another one, this is what the world looks like. Not in the postmodern, every perspective is valid. We can just cultural relativity perspective, but in the very precise scientific perspective, when you have 3 color receptors, you see this. When you have more than 3 color receptors, you see this. So machine learning, the way I define it, just to get our definitions out, machine learning is the algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, relying on patterns and inference instead. So what it does for the social world, I think, is it enables us to see categorical complexity and processes in a way that a lot of scholars, feminist scholars, qualitative scholars have been calling for, that have been impossible under the old methods of simple regression analysis with like survey data. So for example, intercategorical complexity. So when people don't fit the standard categories, race, class, gender, etc., we typically can't study them. So for example, Native Americans are usually a very tiny proportion of survey respondents, so they're typically lumped together with underrepresented minorities or left out altogether. We now have more data. We can capture more data on more people. We can get at this intercategorical complexity in a much more robust way, simply because we have more of it. So if you want to study women who are over the age of 50 who are gamers, you can study that. They're a tiny proportion of the population, but there's enough of them that we can actually get data on them to study. We have very high dimensional data now. So intra-categorical complexity, we are all composed of complex intersecting identities. We have a gender, a race, an income level, etc., that intersect in complex ways and changes depending on the situation you're in. So in some situations, my gender might be most important, in some race might be. So this idea that we can reduce people down to discrete variables, we don't have to do that anymore. We can capture this high dimensional data so we can represent people in this much more intersectional, complex way. Anti-categorical complexity is this idea that we may not know what categories are most important in a certain social situation. Unsupervised methods now allow us to allow categories to emerge from the data itself. So we don't have to impose categories a priori. We can allow the categories to emerge, and we might see categories that we previously did not know or think were important in the data. And then the processes, the type of data we have access to is very different. So people are sharing everything online. We have very intimate data captured through credit card transactions, videos of commute patterns, etc. So the type of data that feminist scholars and other scholars have long really wanted to have access to, that they've done using institutional ethnography, so just observing people. We now have much more of this data, and so we can examine the processes that are really important to the actual way the social world works and the way things like inequality are perpetuated. So the type of data we have access to is different. And this together is this really exciting moment where we can use machine learning to actually change the way we understand society, moving far, far beyond what we used to do with standard logistic regression or regression analysis, using survey data. It's a true moment, as Duncan Watts said, to revolutionize society, the way we understand society in many of these ways, if we apply it in an appropriate way, if we apply it with the appropriate framework. So an example of a machine learning or a data science project or computational social science project that I think did this really well is a project from Sarah Jackson and Brooke Foucault-Wells. They were looking at the Ferguson, Mike Brown, who was shot by a police officer in Ferguson, Missouri in 2014. So this was the early, Black Lives Matter movement. This is when Black Lives Matter movement was really kicked off, was in 2014. And it largely happened, as now, on Twitter. So Sarah Jackson and Brooke Foucault-Wells went to Twitter. They did kind of the standard computational social science approach, where they collected a bunch of tweets and they looked at the core of the network. So they said, you know, who is being retweeted, who are the core people in this network versus based on links, etc. Collect a bunch of those tweets, and their goal was trying to figure out how the discourse was set, who was setting this discourse, how this conversation was having, and how it became such a large kind of national social movement. They did one thing differently than most computational social science studies do on Twitter, is they broke it down by day. So when they looked at who was the core of the network, they didn't just take everything from the shooting until when they were doing their study and looked at the core. They said every day, who is the core, broken down by day. We're going to collect the core by day. And here they found something very different than what the standard narrative was. When they looked at the early days following the shooting, they found that it was local Black women who were largely crafting the narrative on Twitter. So this is an example tweet from IO Miss Darkskin. Ferguson police just executed an unarmed 17-year-old boy and who was walking to the store, shot him 10 times, shake my head. So they were basically live tweeting what was going on the ground in Ferguson, and they were crafting the narrative as it went. A few days later, maybe a week later, this narrative was picked up by large mainstream people like Anderson Cooper, who tweet a lot, who almost immediately become the core of a network just because they have so many followers and they're so influential. So if you look at who was the core of the network in the week following Ferguson, you would pick up people like Anderson Cooper, these kind of big mainstream media types, but they were picking up on the narrative from the local, largely Black women who were crafting it, but they completely drop out of the analysis if your time frame is 1 week. So we have who's really important in the early days of the following the shooting, who is important in the sense of the core of the network in the later days. If you only look at the long time frame, people like Iomis Darkskin don't even enter into your data set. This is what happens when you rely on the average patterns, is it gets swamped by these mainstream average people, and the things that are actually happening, the perspectives from people who were actually crafting the narrative, get completely dropped out of the data set. So it's not that the idea that Anderson Cooper was one of the core spreaders of this discourse is wrong. It's just a particular perspective that you're capturing there. If I am unaware of what is going on in Ferguson and I'm just coming to Twitter, I am likely going to get my information from people like Anderson Cooper. If you want to know who's actually crafting the narrative, you have to break it down and say who's actually crafting the narrative. And there we get the local Ferguson tweeters, people who are crafting it. This is the kind of partial perspective. Neither one is wrong, but be specific about what you're capturing when you're collecting your data in this way. I'll give one more example of this from my own research, looking at intersectionality. I'll go through this pretty quickly, but just an example of how we can use machine learning to capture intersectional identities in a way that like previous methods, regression analysis, et cetera, don't allow us to do. And the example I used in this research is the 19th century US South. The 19th century US South was a heightened intersectional century experience. Black women did not experience the century the same way that white women did. They did not experience the century the same way that Black men did. And we have a lot of history books that explain how this was experienced differently by different people. So we know a lot about this. So that's one of the reasons why this is an interesting case study. So I wanted to think about how we could use computational methods as a different lens into this century to think about how to capture these intersectional experiences using computational methods. So the data I used here is from a digital library called Documenting the American South. It's a collection of primary texts, so first-person narratives from the US South, ex-slaves, women, soldiers, laborers, etc. So a lot of the type of people you don't really see in standard historical narratives from this period, and it's this first-person narratives, which is important. So the data were 414 novel or book-length narratives So long narratives here. So 41 by white women, 89 by white men, 48 by Black women, and 243 by Black men or about Black persons. And I can talk about why I made that distinction there. So my goal here was to measure intersectionality using a computational method called word embeddings, which most of you probably know about here. And I wanted to do this in a way that stayed true to the definition of intersectionality. So I wanted to map 4 combined social identities, Black and white men and women, and 4 social institutions, the polity, the economy, culture, and the domestic, to produce 4 visualizations showing the specific and relational position of each identity embedded within the social institutions as conveyed in the context of pro-abolitionist narratives from the 19th century US South. The narratives that were captured in that library were largely pro-abolitionist narratives. So what's important here is I'm not trying to identify universal patterns that hold across diverse cultures and times, but to be more specific, what is the map of these social identities within different institutions, the polity, the economy, culture, and the domestic, and how does it change within each of these institutions? Partial perspectives, right? Situated knowledge. What is the identities within the polity compared to the economy, culture, and the domestic? Word embeddings, I think as most of you probably know, I'll go through this quickly. It represents text in a high dimensional vector space. So each word becomes a vector based on all the words that co-occur with the word. You can add vectors together, and when you add 2 vectors, the resultant is different than each of the vectors you add together. So to create the social identities, I added an average synonym pairs. So for example, to create the Black women vector, I added women plus Black, plus women plus colored, plus women plus Negro, etc., and then divided by the number of synonym pairs, and did this for each of the 4 social identities, Black men and women, and white men and white women. So this creates this high dimensional space where every vector is related to every other vector, and you can calculate the similarity of vectors based on cosine similarity scores. That's the standard. So for example, the cosine similarity measure between white women and dainty is 0.52, between Black men and dainty is 0.25, showing that white women are closer to the dainty vector in the linguistic space compared to Black men and dainty. So this is what we're doing here. We have this map of all the words in this corpus and these 4 social identities. So I wanted to look at the relationship between these identities within these 4 institutions. So I took the words, the 50 words with the highest cosine similarity score to these 4 institutions here, and that's how I constructed them. And that becomes the institutional space that I'm embedding the social identities within. So there's a lot going on in this graph, but what I wanted to do here was show the relationship between these 4 social identities within these different institutions. So this is the relationship in the culture versus economy, scatter plot, polity versus culture, domestic economy, domestic polity, etc. What's important here, as I know there's a lot of information, is that the culture vector or the culture institution separated by race. So white men and white women were much closer to the culture vector compared to Black men and Black women. Domestic, on the other hand, separated by gender. So white women and Black women were much closer to the domestic vector compared to white men and Black men. So domestic pushed the genders together, culture vector pushed the races together and separated by race. The economy had an interesting intersectional dynamic where Black women were almost equally as close to the economy vector as white men. So when gender schema would suggest that women should be pushed out of the economy and they should only be in the home, Black women were actually much closer to the economy vector compared to white women, and they were equally as close as white men. So the economy was having this interesting intersectional dynamic. So this is a way to show that we can situate our data in these perspectives. So from the perspective of the cultural sphere, what is going on with these social identities versus the domestic sphere, the polity, and the economy. And we can identify patterns that reveal these complex intersecting identities. We don't have to say, well, here's a universal pattern or a universal law that holds across all contexts and identities. We can use this method as a tool to render the unmeasurable measurable, just the way that a camera can render a flower in the perspective from humans versus the perspective of bees and butterflies, we can use machine learning tools to render these perspectives in a way that allows us to see these partial perspectives in situated knowledge. And this, I claim, is how we can scientific and objective understanding of society in a way we previously couldn't do. So that might have seemed kind of obvious. We know that gender and the domestic are related, and culture and race are related in this century. So one other vector I wanted to look at was the authority vector. So there are some competing ideas of how authority worked in the 19th century US South. One idea is that Black men were given a measure of authority, even if it was symbolic authority, over the family, and Black women in order to uphold gender schemas. So there was the standard gender schema of the time, but also to try to stave off slave rebellions. Slave rebellions were a huge threat at this time. There were certain areas where Black people outnumbered and outstrengthed white people, so they were constantly afraid of slave rebellions. And so this idea that we can give Black men a certain amount of authority in the family, and that will dampen their desire to rebel. On the other hand, white women had real authority over Black men and Black women. They could do whatever they wanted to them. They had the actual authority. So there was this idea that white women actually have the authority over Black men and Black women at the time. So I did the same, measuring the distance between these four social identities in the authority vector. This is a slightly different way of showing it. This shows a bootstrapped 95% confidence interval that I constructed. And what I found here was that authority held up gender schema, not racial schema. So Black men were closer to the authority vector compared to Black women, white men compared to white women. White women and Black men were equally close to the authority vector. So there was no sense that, at least discursively, white women were granted more authority compared to Black men. And Black men were statistically significantly closer to the authority vector compared to white women. So in this corpus, at least, this analysis suggested that authority upheld gender schemas, not racial schemas at this time. So that provides a little more insight into this corpus, into a debate that is happening among historians of this era. So this is what I claim machine learning methods can allow us to do in a productive, and I would claim a revolutionary way. So just to sum that up, culture distinguished the races, domestic was distinguished by gender, the economy had this interesting intersectional dynamic, and authority, at least discursively, upheld traditional gender schemas, not racial schemas in this period. All right, so that's how machine learning as a tool, I think, can implement the partial perspectives of situated knowledges, which I think is really needed in the computational social science world. So how do we build a responsible and answerable machine learning system here? I'll just spend a few minutes at the end here talking about this. Responsible machine learning. So how do we blend what we've been doing in the social sciences with this new paradigm here? This is again from Donna Haraway. The science question in feminism is about objectivity as positioned rationality. Its images are not the products of escape and transcendence of limits, the view from above, but the joining of partial views and halting voices into a collective subject position that promises a vision of the means of ongoing finite embodiment of living within limits of contradictions of views from somewhere. This is kind of the statement I want to make about how we can build a strong and responsible machine learning approach to computational social science. It's a view from somewhere. It's the joining of partial views. It is not this idea that we should have this transcendent view from above, which again this is not a social justice claim. This is a science claim. It's not scientific. It's not objective to try to strive for this false god of the view from above. We need to be implementing the view from somewhere. How do we do this? Whose perspective, where is it situated? Whenever you're implementing a computational social science project, ask yourself and talk about whose perspective it's from and where is it situated. So if you're doing a study using mice to look at the effect of a drug, if you're doing the study on male mice, say you're doing the study on male mice. If you're doing it on both male and female mice, say that. It's not about saying you have to do the study from some perspective or another. Just state it. Just tell us what the perspective is. If you're doing a Twitter study and you're using a year's worth of Twitter data, that's going to be very different than a study where you're using a week's worth of Twitter data or a day's worth of Twitter data. You're going to get very different dynamics there. Either one is legit. Either one is a great study, probably. Just be specific about what you're studying. If you're finding Anderson Cooper is the main core person in your network, ask yourself, why, and ask yourself what that is actually capturing. Is it capturing the fact that he's actually driving the discourse, or the fact that he has so many followers and that's driving some different discourse? So it's just a matter of saying, what actually are you studying there? If you're studying mice, male mice, say you're studying male mice, basically. How are you seeing it? So what technology are you using, and how is that influencing how you're seeing it? Again, any technology you use is likely fine if you're doing it appropriately and responsibly, but be clear about what the technology you're using is allowing you to see and how it might be influencing what you're seeing. So how are you seeing it? Whose perspective? Where is it situated? How are you seeing it? And what are the limitations of your vision? There's always limitations, always, always, always limitations. And that's fine. That's part of scientific research. That's how we develop science. So be clear about your limitations. Don't try and claim, oh, I'm doing a Twitter study, and this means I know I'm understanding how discourse happens. You don't understand how discourse happens if you're studying Twitter. You understand how Twitter discourse happens if you're studying Twitter. And that's important. Twitter discourse is important, but we know that it's not representative of discourse largely. So just talk about the limitations of your vision and be very clear about that. Not every study has to do everything. So talk about those limitations. Why machine learning? So when we talk about machine learning, so we can use machine learning to render and visualize perspectives. So when we're talking about why are we using machine learning versus logistic regression, which does just as well at predicting these life outcomes as these sophisticated machine learning models, well, we're using machine learning because we can render these perspectives in a way that is impossible using some other methods. And that's really the power of machine learning. And the power is procedural uniformity. If you do X, you will get Y. It's reproducible. If I give you my code, you can reproduce what I did. So rather than saying, I think I know that this is the conclusion because I did the work and just trust me because I'm a smart person and I know what I'm doing. Machine learning allows us to be uniform about it. If we do X, you will get Y. That doesn't mean you can generalize X and Y to everything, but we know that if you look at a flower from the perspective of 4 color receptors, you will see this. If you look at the flower from the perspective of 3 color receptors, you will see this. We can then debate about interpretation and what it means, but at least we can get those facts straight. So that's what machine learning is giving us here. So the way we can revolutionize knowledge using machine learning, some tips here. Transparency and reproducibility. We can post our code. We can, in many cases, post our data, not all cases. So we can make social science more transparent and reproducible than many of the ways we were doing it previously. So open science, replication repositories, etc. I think probably people in this group are supportive of this perspective. So I just want to reiterate this is important. What to do with small n's. So when we talk about big data, you might not think small n. We're actually dealing with small n's. Twitter is a case. Twitter is an n of 1. Reddit is an n of 1. Yelp is an n of 1. So yes, we have many observations within our case. We have millions of tweets. We have millions of comments in Reddit, but the actual case study is an n of 1. Or if you're doing subreddits, maybe an n of 2 or 3. How do we deal with small n's? How do we deal with cases? We have a lot of work from the qualitative social sciences to think about how we generalize knowledge, how we actually produce knowledge using small individual case or case studies. So the extended case study method from Buravoy, odious comparison from Steinmetz, what can you do with a single case from Pezewitz, exceptional cases from Ermakov. We have lots of scholarship thinking about how you use case studies to build generalizable knowledge or develop theory. So computational social sciences, I claim, should really be going back to this bread and butter methods, largely from the qualitative sciences, to think about how we implement these case studies like Twitter. I keep coming back to Twitter, but there's a lot of Twitter studies out there. So how do we learn from a case study of Twitter? And then thinking about our analytic lenses, there's a really great paper by Jerelmak and Kahn in Socius that talks about how we use analytic lenses in ethnography. And I think it's a really appropriate for computational social science as well. So when you're implementing a social science study, think about your level of explanation. Are you looking at the micro individuals? Are you looking at the meso communities or places? Or are you looking at the macro kind of global patterns? Just be clear about where you are. The subject of explanations. Are you explaining people, places, or mechanisms? All of these are legit. Just be clear about what you're trying to explain. And the location of explanation. Are you trying to explain dispositions? So I am going to behave, I have a certain disposition, a certain habitus, if you will. I'm going to behave the same way regardless of where I am on Twitter, Facebook, Reddit, I have a certain disposition and that will come through in this data? Or are you trying to explain situations? People will behave differently on Twitter because Twitter has a certain type of platform and certain norms. They will behave differently on Reddit, Facebook, etc. So you're trying to explain how the situation influences people and dynamics. Again, either one is important. Just be clear about where you are. There. So transparency, reproducibility, how do we deal with small n's, case studies? What are your analytic lenses? This is, I think, the way we can shift the way computational social science is being implemented into a much more scientific, objective way. This is how I think we can achieve radical objectivity, the partial perspective, situated knowledge framework, not this social physics, universal knowledge, etc. framework. And I will stop there as I am at time. Thank you for letting me speak to you today. Just a note that I understand there is a strike going on at Columbia, and Columbia, pay your graduate student workers. They are the bread and butter of Columbia. They're the reason why you're an elite institution. Pay them well.
Well, thank you for your talk, Laura. It was an excellent talk. I would like to kick us off some questions that may be appearing in the chat. I'd like to start off, if I may, with some questions about your research. One, coming from a mostly qualitative background as a historian and coming into data science, I am very obviously, you could say biased, if you will, towards taking into account various perspectives much more seriously, especially particularly using things like intersectionality. I was curious about, I guess, how you would think about the many ways in which data can be biased towards certain perspectives, right? Like how thoroughly can we, obviously eliminating bias entirely is impossible, but systematically, for example, you mentioned the Twitter data, and the way that we talk about Twitter data as being demonstrative, but really Twitter is a particular network that captures particular kinds of data due to the structure of the platform. And how thoroughly can you take that into your analysis? And how thoroughly can you then use that to make specific claims? So even, for example, even if I'm studying Twitter, say on the Black Lives Matter movement, but I'm only using Twitter data partly because other platforms don't make their data available to researchers, or it's difficult, there's, it's very expensive.
Yep.
How comfortable can we be in even looking at that perspective on a particular platform? How comfortable can we be in our assertions about what we're finding?
Yeah, I mean, we can be very comfortable with them with the appropriate scope conditions, which I think is the point of all of this. So yeah, like we really should be studying Instagram when we're thinking about a lot of social movements these days, because that's where a lot of the action is happening. I've tried to gather Instagram data. It's very, very difficult. And on top of that, a lot of the things that are happening are Instagram stories. So they actually go away, right? We're not capturing those Instagram stories because they're ephemeral. By design, they're ephemeral. So it's data, we have access to a huge amount of data, but it's a very particular type of data, and it's completely dependent on the whims of the platform, which is frustrating. And the platform changes, right? So yeah, it's incredibly frustrating. That doesn't mean we can't do it and we shouldn't do it. I think it's really important to be studying this stuff, and we can learn a lot from doing it if you do it with the appropriate scope conditions. So if you're studying Black Lives Matter on Twitter, talk about how Twitter is different than Instagram. And that can be just like a qualitative, oh, I've done a little bit on Instagram and just observed some differences, or you can think more carefully about who was on Twitter versus who was on Instagram. We know a little bit about who was on Twitter now that Twitter's been around so long. So we know it tends to be a certain type of person who's on Twitter versus Facebook versus Instagram. So talking about that, I mean, we've been doing this for decades in the social sciences. Right? We always talk about scope conditions. We always talk about who your population or who your sample is generalizable to. We just need to keep doing that. We do what we've always done in the social sciences. Who is your population generalizable to? Who is your sample generalizable to? And we can be very confident in our conclusions if we're confident in who is in our study, who is represented in our study. timeline is important. If you're doing Twitter data, are you collecting by the week, by the month, by the year, by the day? What is the day you're collecting and what happened on that day that might influence? So all of these things, which are really hard to think about, and because we need to publish so quickly, the desire to just collect a bunch of tweets and then say something important about them is strong, and people want to do that, but we need to stop and step back and say exactly who is this capturing. I think it's important and we should be doing it, and we can be confident in that, but with the appropriate scope conditions. This is nothing new, right? We've been doing it for forever in the social sciences. We've never claimed that like a certain survey, if it's randomly sampled, is representative of a certain population, right? We know that from sampling theory. We don't know that with Twitter because it's not random, but we can think about who is on Twitter and who is not, and what the impetus of the platform is. It pushes people to be a little bit more polarizing. We know that it pushes people to be a little bit more polarizing. So what does that mean? But yeah, I mean, I think we should do it. I don't know if you're fielding questions. I'm seeing a hand from Henry.
Oh yeah, it looks like Henry has a question.
Yeah, I have a couple. So you're making a case for situated knowledge, but then doesn't that push the problem to figuring out which situation I'm in? Like, given my limited brain space, now I have to have many situated knowledges and assign them properly to the situation, and that can go horribly wrong, I suppose. So is my overall accuracy then improved?
Overall accuracy. I mean, the idea with situated knowledges is that you do actually have a bunch of situations, and what you're doing is you're compiling a bunch of situations to get a better picture of society. So rather than trying to take a snapshot of society as a whole, you're taking a bunch of pictures of small parts of society and putting them together in a collage, more or less. And that's where you get your understanding, your broader understanding of society. So yeah, it does mean that you need to capture a bunch of different situations depending on what you're trying to understand. And it is that piecing together of many different situations where you get this more holistic, generalizable knowledge. And thinking about how you build knowledge from these small snapshots. The problem comes is when you pretend that a small snapshot is actually representative of something that it's not representative of. That's where we get the really problematic conclusions that are not scientific and not objective. So if we just abandon that and say we can't actually get one snapshot of society that explains everything, it's not possible. It's not even not technologically possible. It is logically not possible. It's not something we should be striving towards, even if we can imagine. We can't even imagine this technology that would do that. What we need to be doing is taking these many, many different situations, situated knowledges, and piecing them together. And that is objective. That's where objectivity comes from. So I'm making a strong claim there that this is not like, oh, you're missing some perspective of women, and that's bad for social justice. Not at all. This means if we want to be objective about the way we're understanding society, we have to do it in this way, piecing together these situations. Now, if we're talking about like building a machine learning algorithm and how do we test the accuracy of that, yeah, we do that over many different data sets. That's how we do that, right? Is your model generalized to different data sets? That is kind of a way of saying, does it generalize to these different situations? And you build up your more confidence in your accuracy if it applies to Twitter and Reddit and Facebook and like all these different data sets. That's what people were doing with the scale-free networks and how they started to challenge the scale-free networks. The scale-free network model was really built on like 3 or 4 standard networks. So people like Aaron, what's his last name? Aaron, someone help me out here. He applied it to hundreds of networks and said, actually, it doesn't hold on hundreds of networks. It only holds on about 4% of networks. So this idea that the scale-free model, this preferential attachment, applies to all networks, turns out is probably wrong. It probably doesn't apply to most networks. And there's studies that show that. And the way they did that was applying it to hundreds of networks and showing that it only applies to about 4%.
Can I ask another question?
I'll leave that up to Abraham, I think so, yeah.
Yes, well, Dan Tims, I'm sorry, he seems to have a question. He's had his hand raised.
Dennis Tennant from the English department, also affiliated with the Data Science Institute. So first of all, thank you for this insightful talk. And let me just tell you off the bat, it's like I'm a fellow traveler. I totally take the main line of your point. Like I get it and I support it. There is often a mismatch between the sample and sort of the claims, right? And that seems to be your point here is you're studying Twitter, which is a small subset of a population, and then you're claiming that that's all humans or something like that. Now, what surprised me, and I'm, as a kind of humanities person who does data science occasionally, what surprised me is that your answer is, maybe it's just the usage of the word, but your answer is kind of to double down on objectivity. Mm-hmm. Right, and to say that, and I also get it. You're saying that doing data science right and situated perspective, but in fact, being more subjective about the way we view knowledge leads us to a kind of more correct picture of the world, which I agree with. But I do think that especially the way you discuss postmodernism, and I'm not like committed here. I don't need to defend any historical kind of construct, but I think the idea that objectivity in some sense is not a possible goal or not a desirable goal, and it's kind of the way you did it is to use it as an alternative to universality. But I don't know if that allows you to get out of that conundrum of universality. Just let me give you a quick example, just to make one up. If I'm to study crime in Harlem as a Columbia researcher, is there some objective notion of crime free from human categories or free from the institution of sociology, or however you approach it? So is there some objective reality about crime that I can get outside of my own situated perspective? And I would argue no, and I would argue that crime is a social construct and a legal construct, and any sort of data, any claim to objectivity in that regard would have to sort of be filtered through and that is part of your argument, filtered through a understanding of how we define crime, the history of crime, the history of crime in this particular place, and indeed the history of study of crime from the perspective of Columbia in Harlem, which is problematic in itself, right? So all of those things, and I think that is the postmodern idea that knowledge is ultimately in part subjective. It's not that you can never get to the objective reality, but that subjectivity is sort of entangled in the whole point of view in a quite messy way, and just acknowledging the perspective is like a huge first step towards making knowledge more objective, but also more subjective, paradoxically. So anyway, I'm just thinking out loud with you again. I just want to thank you for this insightful and talk. Thank you.
Yeah, no, I mean, you articulated my perspective there exactly. Well, I mean, so there's kind of two different meanings of the word subjective. The way I'm using the word subjective is that it comes from the point of a subject. No, there's absolutely not this truth about crime apart from society. Crime is a social construct. We have constructed crime as a thing that's part of society. So under no circumstance could we understand crime in a way that is not embedded in some social construct. But that is the point of situated knowledge, is that you say in the context of Harlem, where Columbia has this undue influence. I mean, that's maybe too situated, but like the US has a certain way of thinking about crime. And so we can understand crime objectively if we understand how it is created through the subject of people in the US. But that doesn't mean there's not a truth there. There doesn't mean that there's not a fact and a truth that we can uncover. So this really gets back to Kant, right? His intersubjective reality here. So Kant's arguing against Locke that we can have this kind of view from nowhere. Objects can be understood apart from the way that we interpret them. Kant says, no, we can't. We always are interpreting them from a subject position, but we can arrive at an objective reality through intersubjective validity, right? If we piece together many different subjective views of an object and they all kind of coalesce around a certain thing, we can be more confident that that's the true fact. So he's not saying there's not truth out there in facts. He's saying that the way we get at it is through piecing together intersubjective validity. So this is a long-standing thing. I mean, the extreme postmodern view is that it's all filtered through a true subjectivity, and there's not an actual fact outside of the subject that we're looking at. So this Latourian kind of view of things, like the extreme, like the real deep postmodern stuff, right? So all we can be doing is talking from our own personal perspective, which is exactly what Donna Haraway is arguing against. It's not that we need to talk from our personal perspective. We just need to situate the object from the perspective that we're situating it within, not our perspective, but the social perspective, whatever perspective it's in. So that's the kind of argument against this postmodern idea that there isn't really a truth. It's all just relative. It's all cultural relativity. And that's all we can talk about is like our personal perspective. I think it's a really important distinction. And yes, I'm going to double down. It's objectivity is what we're trying to get at here. True objectivity.
We have a question in the chat from Vishnoy. When building the situated model, how important is the actual similarity index? How important is the actual similarity index used? Is similarity unambiguously a measure of correlation?
Yeah, I'm not sure I understand that question. Are you talking about the similarity indexes in the cosine similarity with word embeddings? I don't know if Vishnoy can jump in and clarify that. I'm not entirely sure what that's asking.
Yeah, my question was, how important is the actual, like I've heard that there's many measures of similarity you can define, and number of formulas to measure similarity, and they can change the extent of results you can get. So going back to the diagrams that you had, where a few points were closer to the line, some were a little further away, I would assume maybe there were some measures that would give you maybe a different arrangement of the set points.
Yes, so you definitely have to validate your measures and your models, and you would want to do sensitivity checks there. It's a good point and a great question. So just getting to the weeds here, if you're trying to measure, in the example I was giving, the similarity between social identities across these different contexts, you would want to validate, is your model actually modeling something real? And you would want to do sensitivity checks, which I built into a lot of analyses, but absolutely some of those kind of standard tools that you're learning through your education and that we implement in data science stuff, we would need to do in this perspective as well. So yeah, validity,
Great,
sensitivity, et cetera.
In that particular study, is the similarity how often the words appear together?
Not how often. It's so the words are rendered as vectors based on all the other words. It's a iterative machine learning method that renders each word as a vector. So are they used in similar contexts? That's what that similarity score is measuring, not frequency, but context. So are the words surrounding each of these words similar? That's what it is. It's intuitively suggesting that they're syntactically close to one another.
I see. Great.
Yeah. So it's all about context, the other words that are used in the same context as that word.
Are there any other questions for Professor Laura Nelson?
Looking at one follow-up.
Oh, yes.
Another question. In the beginning, it seemed to me that you're making a case against sort of big averages or modeling things by averages. Yeah. And in physics, it's one of the ideas that if you're in a high dimensional space, you pick a point at random, you're always going to end up on a surface. You're always going to get an outlier. And so how does it play into your modeling if everyone is in some dimension an outlier, basically?
Yeah, I mean, so the argument here is that don't silence these different silence these different what did you call them, surfaces or whatever you call them, through statistical aggregation. So oftentimes we'll do statistical aggregation, aggregating lots of tweets, for example, and saying, here's a pattern when we aggregate, do the statistical aggregation, that almost by definition it will find the dominant pattern, which in most of the social systems we're studying and the data systems, the data we have access to, is the people who are most common or frequent in that data set. So that will oftentimes be men, not always, but oftentimes be men, oftentimes be white men. So when you're statistically aggregating and you're claiming here is a pattern that describes this data set, you're typically describing a very small part of that data set. And again, that's fine, just be clear about what you're doing. So what you can do with data science methods, exactly what you were saying, you can find islands of difference. You can find parts of the data that don't fit that standard pattern, the aggregate pattern, and you can dig into that different pattern and say, what's going on there? Why does that pattern not fit the statistical average? And that can be, so you can describe that statistical average and then you can move away from it and say, here's the patterns that don't fit. And that's where you're going to get really deep insight into your data, into your social system, is when you move away from the average. Exactly what Sarah Jackson and Brooke Foucault-Wells did with theirs. They moved away from the statistical average that was finding the Anderson-Coopers, and they said, what is going on the edges? And so the way they did that is they just broke it down by day, and they found these pockets of difference. So these early tweeters that were really shaping the discourse dropped out of the data set, the core data set, and they said, we want to bring those back in. So they were finding those islands of difference and explaining what that meant. So that's what it means. It just means move away from the statistical aggregate and think about these islands of difference and how it better describes and explains the social systems. And if you're building tools, think about how your tools might do that as well.
Okay, thank you very much.
I know that we're probably over time here.
Yes, this was a great talk. Thank you so much. I learned a lot. I hope everyone else enjoyed it as well. Thank you on behalf of the Data Science Institute. I hope everyone has a good rest of their week.